Our 44-year-old John Deere 400 garden tractor is still going strong. For winter operations, we connect the tractor to a 45-inch Cub Cadet Model 364 hydraulically operated snowblower. The tractor's front PTO runs the auger.
Okay, the snowblower stopped working, and this is the problem. 45 years old, I can't buy this part, and the spline on this side here is completely stripped. Oh, here, take a look at this. Look how it's worn down there. It's completely worn down. So the shaft going into it is just spinning. Here's the gear reduction unit here. And lots of life there yet.
Let's see if we can fix it. So I can't buy this part. So if I want to keep using this 45-year-old snowblower, I have to fix it. Not being a machinist or having access to anything more than a drill, grinder, and a welder, I thought I would try drilling a hole through the female splined coupler and then drill a matching hole through the male splined shaft. Then I'd just drop a shear pin to connect the splined shaft to the splined coupler. Let's call this plan A. Now, with the fan assembly inside the blower housing and the gear reduction unit with the male splined shaft inserted into the female splined coupler, using an angle drill, I would drill my way through the male splined shaft so I could insert a shear pin. This shaft is hard. Not only could I not drill it with the tools I have, I didn't even leave a mark. Okay, on to plan B. If I can't drill through this shaft, let's try cutting a slot into it using an angle grinder. Now, I know that there are a few of you watching just starting to cringe, recognizing the fact that I'm about to destroy a perfectly functioning male spline shaft. Well, just keep watching. After cutting to the correct depth, I started widening the slot with the edges of the grinder. Here I'm getting pretty confident as it looks like it's going to work. Just need to keep widening it to take a 1/4 inch bolt. Now, look at the splines here. They're not even correctly aligned. Now, I'll figure this out in a minute.
Right there. There's the hammer. So I've spun this around, and now you can clearly see the I don't know, what do you want to say, the teeth? I don't know what they're called.
Teeth of the spline.
And you can see my 1/4 inch bolt right down the middle. So this isn't going to be going anywhere. I'll mark it with a marker so I can take it apart and actually put it in the right direction later. But I'm going to call that fixed.
Here I'm making sure I have the shaft turned in the correct position so the splines slip into their valleys while the 1/4 inch holes remain aligned. Installing the gear reduction unit back on the back of the blower housing.
There we go. So this bolt should go right through. A little bit of persuasion. Okay, that's totally cool. I'm not going to tighten any of this up right now because I want to get the axle in there first. And once I've got the bolt in through the axle, then I'll come back and tighten all of these up. Well, I just removed 30 minutes of cursing. And I got it in.
Quick assembly of the auger. Very straightforward procedure after you have the drive axle connected. Okay, this is working. The snowblower is back in service. Uh-oh. Okay, let's see what happened here.
Let's hope it's a broken bolt and not a broken axle. Holy shit. It broke right off. Holy crap. Okay, was not expecting that. I thought for sure that the bolt or the quarter-inch bolt from Home Hardware broke, not the entire axle. I am blown away by this. So, that was a bad idea. Look at this. This is a 1/4 inch bolt from Home Hardware. It'd be grade 2, which means it's essentially a shear pin. They're designed to break. They're not designed for this purpose. I was expecting that to break, but instead the axle did. Just can't believe that. Anyway, you can see there's no splines left in this at all, so I'm gonna have to get this machined. So that's the game plan. So I'm gonna take my spare unit right here, which I just rebuilt a few months back, and take it into a machine shop and see if we can get this fan blower assembly machined. I'll have to figure out, somebody smarter than me will have to come up with something, because you cannot buy this part anymore. It's 40 years old, discontinued about 18 years ago.
So after taking some very precise measurements, my 13-splined shaft is 21.5 millimeters from ridge to ridge and 18.4 millimeters from valley to valley. It's about 32 millimeters long. So I need to buy a female splined coupler that matches this male splined shaft. I found one at Prairie Bearing and Bolt in Manitoba. So now I need someone with tools, talent, and experience. I reached out to Jason Badham at Valley Welding and Millwright. I want to take a moment to recognize Jason and his team at Valley Welding and Millwright for sponsoring this video and for the incredible work they do. Valley Welding is known for their skill, precision, and versatility, tackling everything from custom fabrication and structural steel to millwright services and on-site repairs. Whether it's a small custom project or a large-scale industrial build, their commitment to quality and craftsmanship shows in every weld and every detail. Jason and his crew take real pride in their work, and it's that dedication that makes Valley Welding a trusted name across this region.
So you're clamping down the piece here, and then we're going to move the drill bit.
Yeah.
And that's not the bit we're using.
No.
This is a slightly smaller outside diameter. So literally we're going to be cutting this size, and essentially it's just going to...
Yeah.
What do we got?
So it's 1 3/8.
1 3/8, okay. So what are we doing? You look for the drill bit size?
Yeah, this chart's in metric, but 1 3/8 is 35-ish.
Okay.
So A1.
So that's basically, we're setting the speed of the drill bit.
Yeah.
Okay. Very slow.
Pretty slow.
Now let's watch this drill work into the hardened steel splined coupler. You can see it's moving really slowly, somewhere around 1/4 of an inch per minute, which shows just how much precision and patience go into this kind of work. Even with this big 1 3/8 inch bit, the drill press handles it steadily, making sure the hole is clean and accurate. Here I've speeded up the video significantly.
So just real quickly, what's the game plan here? We have to drill out one side.
Yeah, so we're gonna drill halfway down,
Okay.
just to take the bulk of the material out.
All right.
And then we'll put a boring bar in it, and we'll clean it up with the boring bar.
Okay. And there's no hole. We do the hole later?
Yeah.
Okay. All right. Perfect.
So we're doing it on a lathe to get it centered, but it's still, it won't want to drill centered.
Yes.
So I'm gonna drill it undersized, and then I'll bore it with a single point to final size.
Gotcha. Gotcha.
Cutting speed at 70 times 4 equals 280 divided by, that's 0.8 drill, 350 RPM, 270, 370.
Okay.
So I'm going to select the lower end of the
Okay.
1.5. So now I know that that's in 1.5 inch.
Checking in on our drill press to see how it's coming along. Again, speed it up significantly here so we can see the drill bit pop out the bottom of the female coupler.
Holy, look at this.
Back to the metal lathe. This is a pro lathe gauge. It's used to set the height of cutting tools, including boring bars, so the tool tip is exactly on the spindle axis.
You want to have everything on center, so I'll put this in first.
Okay. DRO.
Digital readout. So this is, the DRO has linear scales on it.
Yep.
So I'll take a cut, zero it.
Okay.
It has scales on both sides. So I'll set 0 and then I'll set it to 1.5.
As far as depth goes.
Depth goes.
Gotcha, gotcha.
This is 3, so we'll know that from the edge in, it's exactly half. Saves the guesswork. Because it's a single point, a drill bit can wander as it's drilling.
Yeah.
Whereas this technically, it will to a certain extent from deflection, but it's more likely not going to.
Okay.
And you can now tailor the size more accurately.
Okay.
Like a drill bit, it drills, it's supposed to drill the size, but it usually drills oversized.
Yeah.
Just because the way it's sharpened, external forces, you know,
Yeah.
a bunch of things.
So it's a common practice to undersize on the drill.
Yeah, you want to undersize it. And then you also want to make sure that this boring bar is not sticking out further than it needs to, because it helps with deflection. I'll zero this too. Now I know that that's where we were cutting. Still too tight.
It's okay. I like this approach of sneaking up on it.
Yeah, I'll measure down here because it is tight. Then where you measure, 85, see it's out around as well. And then back here, it's 84.
So I guess we have to take the widest then.
And down here, yeah.
My money is it fits.
So now what I'll do is I'll measure. I'll transfer that over and I'll drill the hole.
This is a great view. Splines on one end and a smooth shaft entry for the axle on the other.
All right, we got to drill a hole pretty much where my thumb is, right there. Look at this. We're done, man. Like
This is so
Cut
cool.
it down to here,
Yeah.
over to here,
Yeah.
up, across, and then the same, and then the same. And then we're going to remove this slug
Okay.
so that essentially we're going to have a lineup pilot surface in this area on all 4 coordinates.
With the slag and the cut debris removed, we used a press to push the coupling home.
So now it's test fit time because we can move it
Okay.
if need be, but we can't move it after we weld it.
Perfect.
Jason did a fantastic job. I could have never done this at home. This snowblower broke down in February. After my own failed attempts, let's just call them lessons learned, plus the time spent sorting, finding, and ordering parts, and then booking time with Jason, half a year has passed. The older equipment gets, the harder it can be to look after. From what I've been able to determine, they've stopped making replacement parts for this 45-year-old blower about 20 years ago. Without Jason and Valley Welding and Millwright, this might have been the end of this machine. But thanks to them, it has new life, and with some creativity and a little perseverance, it might have many years to go. Hey, thanks for watching.